So welcome to the session. My name is Simone Bordet. I work for an American company called WebTide. We provide services and support for Jetty. And I'm here to present you what we have done lately on the Jetty space. So Jetty is an open source HTTP server and server container. And it was founded in 1995 by Greg Wilkins. And there's a nice story around this because at the time there was this company called Sun Microsystems that was pushing out a new language called Java, and it created a contest for the project that could write the best application written in this new language. And so Greg Wilkins submitted this web issue tracking system. And the idea was that, that was a cool project at the time and written in this new language. And so it was, show how nice Java was. And so in order to write a web issue tracking system, you need to write a web server first. And that's where fundamentally Jetty started. It started from there, and then it evolved, and then people liked the serverless stuff, and etc. And so we're here today still. It's almost 30 years. And we're still kicking ass. Over these years, Jetty was one of the innovators in the Java world, especially on the server side. We were the first server to be completely using non-blocking APIs that exited in Java 1.4, Java NIO. We created on top of that a library called the Jetty Continuations. And inside this library, there was basically this idea that you could do asynchronous processing of requests. Remember that these were the times where non-blocking I/O, asynchronous processing, reactive, etc., was not even on the scene. And so we were pioneering these things. From the experience of the Jetty Continuation, basically this was later standardized as what we today know as the Servlet 3.0 asynchronous servlets. We were the first server to implement WebSocket, as well as the first to implement the Speedy, which was the predecessor of the HTTP2 protocol. We also support PHP, we support PHP, and for example, PHP is interesting because the way that we support PHP is the browser sends a request to Jetty. Jetty will convert that request in HTTP into FastCGI, send the request, FastCGI request to a FastCGI server, which will contact the interpreter of the PHP application that you have installed. For example, WordPress. You generate your web page, send it back to Jetty. Jetty will convert it back from FastCGI to HTTP and send back to the browser, right? So this is actually the way that we run our own website. WordPress is such a nice, tool and application to have dynamic pages for websites and so on, and so that's the way we run our own website. So who's using Jetty? And it's now kind of an infrastructure tool. It's a web server, a server container, so people don't really use that directly anymore, but it is of extreme importance for all the people that provide services on top of that. So for example, Google App Engine and Web Functions and the Google Cloud in general, if you're writing a Java application and you want to deploy it into the Google Cloud platform, you're going to be deployed into Jetty. And the Salesforce backend works on Jetty entirely. Yahoo, Cisco, American Express, but also, for example, the database engine that was created in Facebook called PrestoDB, now it's a separate open source project called Trino, uses Jetty on the server and on the client to perform distributed queries across a cluster. Snapchat is one of the applications deployed in the Google Cloud that everybody uses in the world and runs on Jetty. So we are well deployed around. It's just that we are at one level below what people normally notices, but we're still doing good. And because we have been on the scene for so long, we are very well integrated with many other open source projects. So we have integration with Spring and Spring Boot. We'll see this throughout the presentation. With Javelin, Drop Wizard, Gerrit. I mean, there's plenty of projects. Just to look at the dependencies on the Jetty projects on GitHub, there's 40K plus other projects that depend on Jetty. Why do you want to use Jetty? Well, it has a friendly open source license. So it's the Eclipse license or the Apache license. You can choose to elect either of these licenses. It has a company behind it. So it's not a one-man midnight effort that if the guy goes into vacation, then you don't have support anymore for the Jetty project. There's a company behind. There's a bunch of developers that are employed to actually work on Jetty. It has a lot of features. We support like all the web protocols, WebSocket, HTTP2, HTTP3. It's fast, it's scalable, it's flexible. It's very modular. You only enable the modules that you need in Jetty, and it's highly customizable. So, for example, we still have some of the load balancers that ping the server in order to understand whether the server is alive or not using HTTP 0.9. And HTTP 0.9 comes from the 80s, and it's now 40 plus years old. It was never actually widely deployed, but these guys still use it to send something to the server and say, hey, I want to know if you're alive or not. And well, we support that in Jetty. I mean, it's obviously a very deprecated version of the HTTP protocol. It's not really secure and everything, but you can tune Jetty to say, hey, I want support for HTTP 0.9. We have support for Spring as well, which is, you know, today is basically like, I don't know, 80% of web applications are probably written against Spring APIs. So we have that. We're always innovating, so we are always on the latest RFC, on the latest you know, researches and interesting stuff that is happening on the web. For example, we were, you know, cookies underwent a, you know, substantial changes very recently. There were like a couple of attributes that changed the way the cookie works. And we were one of the first to implement and give this possibility to say, oh, you can now in your application add this cookie. We would understand how this means in Jetty, and we would produce the correct HTTP header for with this particular attribute. We focus on providing HTTP fundamentally and web protocols. We are fully Jakarta EE compliant, but we don't push. If you want to use something that is Jetty specific or simpler or leaner, you can. And the other thing is that we are not only a server, we also have all the clients for all the protocols that we support. And this is important because we use our own clients to test ourselves. And so we have, you know, client implementation for HTTP1, HTTP2, HTTP3, high level, low level, WebSocket clients, and even the FastCGI client if you really want to do that. These clients are heavily tuned for massive scalability. For example, we run every night the performance tests against the Jetty server. We need 4 client machines, and we typically run the total number of requests per second at about 480,000 requests per second against a single Jetty server. And then we publish the results that we have on that particular thing. And, you know, we're down into processing a very simple single request is going to be around the, you know, 10 microseconds, something like that, even at that rate. So we use the clients and the very scalable clients that we have to do that, to impose that load, because typically in a load test, the client is the one that dies first. The server, on the server side, Jetty can, you know, stay there, handle 480,000 requests per second, and say, okay, send me more, no problem. Because we have a client and a server, we're perfect for example, implementing microservices or proxying, right? Because you receive a request and you act as a server, but then inside the logic that you have, you want to say, oh, okay, I'm a microservice, but in order to fulfill my task, I need to call 3 other microservices. How do I call them? Well, I need an HTTP client. And so you can be very efficient. For example, you can say, hey, I want to call these other machines using the HTTP2 protocol low level. I want to deal with frames in the HTTP2 world rather than the high level get / some request / HTTP whatever, right? So yeah, we have support for that, and it's really, really efficient. So let's talk about Jetty 12, which is a specific version that supports Jakarta EE 10. As you know, there was a big move by moving all the enterprise API from Oracle to the Eclipse Foundation, and therefore there was this big move from JavaX stuff namespaces to Jakarta namespaces. And the one thing that went kind of undercover, though, is the following, is that finally, after 20 plus years of existence of the Servlet specification, the Servlet 6 removed from the API some of the deprecated methods that were there, and they were deprecated from 16 or more years. So if you want to deploy a Jakarta EE 10 application, you need a modern server. And it is not always the case, like it was in the past, that if you have an old web application, like a legacy one, and then you deploy that application into a modern server that only supports Jakarta EE 10, that might not work, because maybe the old application is using these methods that were removed, or there were also some changes in behavior which your old application might have relied on, all right? So what does this mean? It means that if you have a system with many different applications that come from many different sources, now you start to be needing different versions of servers in order to run them. Like the new ones runs on Jetty 12 or Tomcat 10 or whatever you use, but then you also need Tomcat 9 to run the old one, or Tomcat 8 to run the even older one, and so on and so forth, right? So, and then it becomes more of a management of all these servers, because now I need 3 different versions. Did I update this one but not the other ones? And it's going to be complicated. And it was also complicated for us developers, because we would have to maintain the branches, the main branches for the main Jetty versions, like almost forever. We will need to maintain Jetty 9 to support Java 8 and Jakarta EE 7. We will need to maintain Jetty 10 and 11 for Jakarta EE 8 and 9, and so on and so forth, right? Because people would still say, hey, I still have my legacy application here that I cannot move to EE 10, and so I need to deploy that thing into a web application server that actually is able to run it, and so I need Jetty 10 to do that, or Tomcat 8, or Tomcat 9, whatever, right? And so this is the way the Tomcat, for example, went. It said, okay, every different major Tomcat version supports a different Jakarta EE specification. So if you really need to run old web applications and new ones, you need 2 different Tomcat versions. But we chose a different way. What we have done in Jetty 12 was to completely separate the core engine of Jetty from the Servlet API. So what we have done is now we have a core engine that is a base, and then on top of that, we have server container implementations. So what we can do now is, because we have this core, we can also now allow developers to write web applications using just the Jetty API. But if you want, and so by doing that, what you gain is that you do not have anymore the serverless specification overheads, and so you immediately gain like a 15% performance benefit from that. We have blogged about it. We have the daily performance test that I talked to you about before, and this is, an easy 15% gain if you don't really want to stay on Jakarta EE if you want to do that way. However, if you want to stay on Jakarta EE 10, 8, 9, 10, 11, and so on and so forth, what you can do now is fundamentally this. You install just one version of Jetty, Jetty 12 or 12.0, 12.1, whatever that is, right? We go on a minor version for Jakarta EE 11, it's going to be 12.1, but then when Jakarta EE 12 will come out in the future, we're probably going to be Jetty 12.2 or something like that, right? But you install only one version of Jetty. That's the key point. And then that one version of Jetty will be able to run Jakarta EE8 as well as Jakarta EE9 or 10 or 11 or 12 in the same server if you need to do that. Or even if you don't want to run different web application in the same server, the benefit would be that you install some in your machines, just one version of the server is going to be the latest Jetty 12.1 version, and that version will be able to run the old legacy application in this container, but then in this other container is going to run a new EE10 web application. In that other container is going to run yet another legacy application, maybe it's EE8. In this other very old container, you can run, you know, a super old one, which is maybe Servlet, you know, 3 or whatever, okay? This is perfect because now you can have a single server that can allow you to slowly migrate your legacy applications if you really want to. And you get the benefit of running on a modern server because, of course, all the magic that we're doing implementation-wise, we're doing it on the latest Jetty version. We don't backport, for example, a lot of you know, modern stuff support into very, very old branches of the Jetty project. So, for example, that means, in particular, virtual thread support is very well done in 12, but it's not done at all in Jetty 9, right? So you have a modern server that runs your possibly legacy applications without problems. So one thing that was very interesting that we had, of course, not implemented at the very beginning was cross-context dispatch. How many of you know about cross-context dispatch? Probably nobody? Okay, cool. So what was possible from the server specification was the following. You had two web applications deployed on the same server, and you could say from one web application to do the following. I know that there is a sibling web application deployed in the same server. I want to take this request and send it to that particular web application, but not going through the network, right? Because I know that they are deployed in the same server. Okay, so now if we're able to run different EE versions in the same server, how does it work that I have a JavaX request class that has to go into a possibly different web application that now has that same class, HTTP servlet request, is now a Jakarta HTTP servlet request, right? It's a completely different class. So the way that we have done it is, of course, we haven't done it at the beginning because it was like, okay, well, who's using cross-context dispatch? Nobody. Until we come out with the first versions of Jetty 12, and then one of our customers raises the hand and says, oh, but we're using that feature. Can you do it for us? And so we have implemented now cross-context dispatch. And what we're doing, we are now able to basically take a JavaX request, do the magic, make it look like a Jakarta request, and send it over to the other web application and get it all the way back. So this is sometimes the reality that you get in large deployment, especially with large customers that have a variety of departments that go into the same you know, final product and say, okay, this is what we offer to our clients. You know, there's multiple versions, multiple technologies. This was one of those that was possible to use. They used it and needed to be implemented. But with the JavaX Jakarta problem, we had to do some magic. So we have also integration with the latest Spring versions. And the good thing is that right now the integration from, so you write a web application using the Spring API, say Spring MVC. What happens under the covers is that Spring MVC binds to Jakarta EE10, and then the servlet container that is below, either Jetty or Tomcat, will understand completely, okay, so this is a Jakarta EE10 request and response, I know what to do, and it just does it. What we have in collaboration with the Spring project, we have done the following. We have said, okay, now that we also have our own web APIs, fundamentally, we have issued a pull request to the Spring project to say, hey, when people write an application using the Spring API, instead of binding to Jakarta EE10, you can bind directly to the Jetty API, and then you have the 15% performance advantage. And so this is a pull request, is going to be integrated in the Spring project. And so this is nice because as the Spring and Spring Boot project have a way to select Jetty rather than Tomcat, we also, the collaboration goes also the other way around. So we issue a pull request to Spring and say, hey, you can use Jetty in this more performant way. So how does it look like when you want to install Jetty and use it as a standalone server, which is the typical, I installed this thing here, it has a web apps directory, I drop a war in there, boom, my web application gets deployed, right? So the way that we have set up Jetty as a standalone server is through Jetty modules. So every feature of the Jetty server is inside a module. And you can say, I want these modules to be enabled and not these other modules. This is really good because you don't have like a big fat server that does everything, like it does HTTP1, HTTP2, WebSocket, FastCGI, hot deployment, static deployment, blah, 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 like all the features. You installed a big thing and then maybe you just use HTTP1, like, and all the rest is there, but you don't really use it. So the way that we do this is, no, you actually pick and choose whatever you wanna use. And this is also good for security reasons, right? Because if you don't use WebSocket and you're meant to not use WebSocket, well then when you receive a WebSocket upgrade request, the server will just fail and say, hey, you try to upgrade to WebSocket, but I don't have the modules here enabled that do that. So sorry, I cannot do that. And so it replies with an error. So the way that you do this is fundamentally you put the shared Jetty runtime in one place, and then you configure a different directory with the configuration and the modules that you want to enable for your web applications. Okay. This makes super easy to just update the runtime of Jetty. Whenever we go out and say we have Jetty 12.0.5 and then 12.0.6 come out, okay, well now you can update the runtime. You do not touch any of the other configuration directories that you have where your web application will be deployed. You just update the runtime and poof, done. Magically everything works again. So what you do is that you go to an OPT directory, for example, you just unpack the Jetty home distribution for certain things, and then you go to a different directory, say user local, you create this Jetty base concept directory, and then you say you enable certain modules. So for example, here you have add modules HTTP. And so you give Jetty the capability of understanding HTTP clear text, HTTP1 clear text. And then you just start the server in this way. And Java -jar, Jetty home start.jar, easy. What you can also do, you can say, okay, well, I can set up, in that particular setup configuration, I want to add more capabilities. So for example, I want that particular configuration to also support HTTP2 and also the deploy module, which allows me to do hot deployment into Jetty. And also I want to enable the JMX support because I want to be able to connect via JMX console to the Jetty server in order to see the state, the internal state of the server, right, that we expose as JMX mbeans. Once you have configured all the modules that you need, you just restart the server and off you go. And of course, you can have multiple Jetty-based directories. For example, you can say, hey, this is my administrative web application, let's say. I want to configure a particular directory with all the modules that I would need for the administrative web application. Maybe it's super simple, you just need HTTP1. But then you have another directory where you say, oh, but I want to use the Jetty PHP FastCGI support. But that is not needed for the administrative directory. No problem. I create another Jetty base. I enable, for example, here, HTTP1 with TLS support, FastCGI, and hot deployment. And I just add those modules, and I'm good to go. And so every module creates a configuration file, because of course you can configure every feature of Jetty, right? For example, for the HTTP module, what would be the port that Jetty listens to, right? So every module has a correspondent INI files, and inside the INI files you can find properties. And these properties, you can specify them on the command line in this way, where you basically set on the command line, hey, the port that I want you to listen for HTTP is not 8080, it's not 80, but it's 9090 in this particular case. You start the server, and the server starts on port 9090 because you specified it on the command line. But then you don't want to, maybe you have now 20 modules and you have 30 different properties. You don't really want to, store the 30 properties on the command line. So what you can do is just you change the INI file and store the properties there, and then Jetty will just read all the configuration and starts from there. The old deployment that we've seen in the past, well, now there's the cloud, etc., but this is kind of still valid, was, well, there's the browser speaking HTTP, it goes to some kind of Apache frontend or Nginx frontend, and then from there we go back all the way to the Jetty or Tomcat or whatever in the backend system, right? And the way that we talk to the backend is going to be AJP really old or HTTP 1.1. This is really obsolete now. We don't want to do that because now browsers do not speak only one protocol. They speak three protocols typically: HTTP1, HTTP2, HTTP3. And what you want to do is you want to try to avoid conversions between a protocol, say HTTP2, into HTTP1, right? When you talk to the backend. Because there are better solutions. Fundamentally, you can put a proxy in the front, like HAProxy, for example, that does very efficient TLS offloading. So all the encryption part is done by HAProxy, and what comes out of it is what? Well, let's assume, for example, the browser speaks HTTP2 encrypted. It lands on HAProxy. HAProxy does the decryption. Okay, so now you have a bunch of bytes that are HTTP2 clear text, and you don't want to parse those bytes, which are binary bytes, do all the effort to convert all those bytes into a textual representation that is HTTP 1.1 that says get space / resources blah blah space HTTP 1.1 /r/n, and then do all of that for all the headers, concatenating string and etc., and then sending them over to the backend, because that's a lot of work. You're going to spend a lot of memory. You're going to copy all the HTTP2 bytes that you already have. You don't want to convert them into HTTP1. Why? It's just wasted effort. Just take the bytes that HAProxy has just decrypted, you shove them into a socket towards the backend, and Jetty will say, hey, thank you, I know how to deal with HTTP2 now, and I'm just gonna, present, parse the HTTP2, present it, call the application will do the magic, I will do HTTP2 again, send it back to HAProxy, HAProxy will crypt them and send back to the browser, right? Unfortunately, this is not possible with HTTP3 because HTTP3 is a little bit special, but we still provide the capabilities in Jetty to be able to listen to HTTP1 and HTTP2 clear text. So this is a very good way of deployments for very efficient setup on the server side, especially across, forget about HAProxy for a second, but if you have this set up across microservices internally in the backend, that's exactly what you want to do, right? You want to take a request and then you want to, communicate everywhere through HTTP2 just because it is more efficient than HTTP1. or you want to say, okay, maybe HTTP2 is not my use case, I want to use HTTP1, okay, you can do that. Or you want to use a mix of the two things, you can, because the Jetty HttpClient will be able to say, hey, for this server, you're going to speak HTTP1, but for that server, you're going to speak HTTP2, right? Okay, so that's enough for the standalone server, but Jetty is also well known to be embeddable in your code. So we have APIs that allows you to do that with just 2 lines. New server 8080 start. You just create a Jetty server that listens on port 8080. What does it do? Well, absolutely nothing. We'll reply 404 to every request because there's no logic that you have configured in here. But we allow 3 different, in general, 3 different ways of configuring your logic, right? The first one is to use directly the Jetty Core API. So typically what you do is that you have your server, and then you create a context handler, which is the representation of a web application. It has a context path, which is typically, you know, when you deploy a WAR, it's typically the name of the WAR file. And this case is app, right? And then you just say to the server, hey, all the logic goes through this handler, right? And then you write your particular logic in a child handler to the context handler. So you have a context handler that defines this is a web application, and then you have a child handler of that implements your own logic. You write the handler, right? So in this particular case, it just succeeds the callbacks and returns true and says, hey, I have done nothing here, but it's a 200 OK response back to the client, okay? I handled the request, but you can put whatever your logic you want in there. The second way that you can do, and so this is the Jetty Core one, is the one that is 15% faster than the Servlet one, and it's efficient, it's, you know, easy to use, and it's very efficient. Yeah, as I said, less overhead, smaller memory footprint, fully non-blocking, but again, we're still committed very heavily to Jakarta EE, and so we have a top-notch implementation. We passed the TCK for Jakarta EE 11, and so you can write the same stuff in code but using servlets. And so there's 2 ways to do this. The first one is you just put everything into a single class path, right? So you have the Jetty classes, you have your classes, your dependencies, everything is in a single class path, okay? And then you create a server context handler, and then you just add your servlets, exactly like you would list your servlets and add them into a web.xml file when you create a WAR file, okay? Here, you just do exactly the same, but in code. Lastly, we have this last way of deployment, which is fundamentally the same that you have of a deployment of a WAR file into a standalone server. You just create a web app context, you give it the location of the WAR file or the WAR directory that is structured in the same way, and then you say, hey, you tell to the server, hey, this is the handler that I would like you to use in order to handle this particular web application. And off you go. The WAR will be exploded, it will look inside for the web.xml, it will figure it out what's inside, process everything, attach servlet filters, servlets, and all the configuration that you have in your web.xml. It will give you class loader isolation as the inverted class loader model that Jakarta EE servlets provide, and everything will just work. This is a simple example where you replace Tomcat with Jetty. This is the whole XML that you do that. On the top part, you say Spring Boot, use Jetty. And in the bottom part, fundamentally, you say Spring Boot, exclude Tomcat. And that's it. That's all you need in order to use Jetty instead of Tomcat in Spring Boot. Virtual threads. We support them in 3 ways. One is no virtual threads. We just use platform threads for everything. The second thing is we use a mixed version. So for some internal things, Jetty will use platform threads. but then when it calls the application, it will use virtual threads in a very efficient way. And the last way would be only use virtual threads, right, for everything. There is a downside to this, that the core of Jetty is still written using asynchronous I/O, and especially the select operation pins the virtual thread carrier, and so you would have one of the threads that it's a carrier thread for a virtual thread that is running the select operation. That thread would be pinned, which is a problem for virtual threads. But as long as you configure Jetty properly, you would have a few virtual threads pinned in the select operation, but then you would have many other carrier threads available for normal virtual threads. We went through a lot of work in order to support virtual threads in Jetty, because it is not as easy as saying, oh, I'm just going to replace the thread pool in front of Jetty with a thread per task virtual executor, and I'm done. No. It's not that simple, because there's many things that need to be taken care of. For example, we used to have synchronized object waits in Jetty, but now we don't anymore because we have replaced everything with Java util lock. Virtual threads are known to trash thread local caches. We had thread local caches in Jetty in order to compute expensive stuff, but now we cannot use them anymore, because if we run with virtual threads, then they're going to be trashed and the performance will suck. So we have introduced a specific Jetty class called thread ID pool to solve this problem. Note that this problem it's quite particular. For example, the JSON library, if you use JSON or if you use REST services, JAX-RS, and producing JSON, likely you're going to use JSON as a library. If you use JSON as a library and you use virtual threads, you're going to encounter this problem. You're going to trash thread locals, because internally JSON uses thread local to compute the metadata for the classes that it has to convert to JSON. And so what happens is that a request comes in, there's no data, JSON computes the expensive metadata and then proceed with the request. But then that thread local, because it is bound to a virtual thread, goes away. And so the next request comes in and JSON looks at the thread local for a new virtual thread and it's going to be empty. And so JSON will compute again all the expensive metadata and then proceed with the request, just to be thrown away again. And so now you're going to trash all your local caches, and we don't want to do that. We had the same problem in Jetty, but we fixed it. The other problem that virtual thread introduces is that they open up for unlimited load, right? When you had a thread pool at the front and you said max number of threads is going to be 100, well then inside your system you could have had only at most 100 concurrent requests. Now, if you put a virtual thread pool or virtual thread executor in front of your web server, what is the limit? Well, there's no limit. For every request that comes in, there will be a virtual thread. And this means that if you have a load spike, you're going to hit a load spike into the server, and so the limit that you had before doesn't apply anymore. And so now your system is likely to go down due to out-of-memory errors. We solved that too. Now we have a virtual thread pool. We don't really pool virtual threads. What we do is that we apply a global limit to the number of virtual threads that can enter the system using a semaphore. The last thing that we fixed with virtual thread is that they're very difficult to troubleshoot, right? So imagine the situation where you have 100 requests in your system, all of them arrive to a global lock that protects the JDBC connection pool, okay? What would happen is that all the 100 virtual threads will be parked, and then if you take a snapshot at that moment of the system and you do a thread dump of that particular system, what you will see that almost all the carrier threads will be idle in the pool. And so you look at the system and you say, well, this system is doing absolutely nothing, because the thread dump doesn't give you the thread dump of the parked virtual threads. So now you have to use a more complicated tool, jcommand. If you use jcommand, well then yes, you can also see the stack traces, but in order to use jcommand, you have to have access to the machine, and it's becoming a lot more complicated. So what we have done is fundamentally the classes that we have in Jetty instead allow you to dump the state of the server. It means that you can dump into a string the whole state of the server, meaning all the connections, what is their state? Are they blocked in reads? Are they blocked in writes? You can dump the state of all the threads, including virtual threads. You dump the state of all the Jetty components that are actually attached to the components of Jetty. And so how many, for example, handlers do you have? How many web applications you have deployed? Under which context path? And so on and so forth, right? So this is really priceless. Lastly, we're talking about the clients. We have a high-level HTTP client. This high-level HTTP client is able to speak HTTP 1, HTTP 2, HTTP 3, but also FastCGI, and even custom protocols that are similar to HTTP. And we also transport those protocols over different transports. So we can have TCP, which is typical, but also Unix domain sockets, but also quick. So for example, we can do strange combinations like HTTP1 over quick, which is kind of weird, but we can do it because we have separated these two concepts, or even through memory. So that would be very efficient. You receive a request and then you pass it to the client, or the client passes it to the server through memory without going through the loopback interface or through some other network thing. It has a fluent API, and it's heavily event-based. That means that, for example, you can have an on-request begin event, and you have an on-response begin event, and on-complete event, right? And this is really useful because this client will now allow you to write very precise load testing tools, because you know exactly how long the request has been queued, when is it exactly that it started to be sent over the network, what is the time to the first byte that you get from the server, and what is the time to the last byte that you get from the server. So you can gather a wide range of statistics about what's going on in your clients. And you write a load test tool to doing that, and that would be really nice to have. We also have the low-level HTTP2 and HTTP3 clients. If you really want to deal with the low-level HTTP2 frames definitions, you can do that. We have an API that allows you to do that. And that allows you to, for example, speak gRPC or manually. Or if you want to invent your own protocol on top of HTTP2, you can. Same with the WebSocket client. We have this WebSocket client, and we even support WebSocket over HTTP2, and in the near future also over HTTP3. And so this would allow you to fundamentally use this single client, no matter what the server is talking. If the server is configured to only speak HTTP2, you can still talk WebSocket to that particular server. So that's basically it. I have completed the round of things about Jetty. I hope you will be interested in what we're doing. As I said, we're still innovating, and we blog about things and stuff. We are very open to as a project, and there's going to be this afternoon in the Coding Lounge session. I will be there, and if any of you is interested in contributing a small pull request, very simple, to the Jetty project, I will guide him to do that. And the ones that come and submit stuff will also get a Jetty t-shirt. So please come. That's it. Thank you for listening. And if you have questions, I'm here.